guys can finish your conversation. Who is it then? A way to name a function that is an equation with an input and an output. When we talk about inputs, what letter do we usually use for input? X, good. And what do we normally use with an output? Y. All right, so that's kind of a long definition there. Make sure you get that written down. Hey, do you have a pass? No. Okay. All right, in the middle of taking notes, so go ahead and do that. A way to name a function that is an equation with an input and an output. All right, so as we look at this, the first thing that we're going to do is it kind of looks goofy. It's f and then parentheses x. F parentheses x. And we're going to say equals x plus 2. So f is what we call the function name. Okay, this one doesn't get any fancy names. It doesn't get Miss Morel or Adam or Celine or Naya. It gets just a very boring one-letter name. F. I know, right? All right, and then X is our input, as it's been. And this x plus 2 is called the rule, like the function rule. It's what telling us what to do with it. All right, so if I start with f, and I have 3 in the parentheses. 3 is which part? The input, or the x. So this is telling me to put 3 into the function and do the rule using 3 as my x. So what would that equal if I put 3 in, and I did that with my x with my rule? I would do 3 plus 2, which equals 5, which then tells me my output. So it's kind of a different way to write our ordered pairs. Instead of writing x, y as an ordered pair with those parentheses and comma, it tells us a little bit more specifically. It's telling us that we put it into function f. This is that function f that we put it into. We get out 5. If you need to write that 3 plus 2 above it, just to remind yourself how we got 5, you can. Caesar, what's going on? Okay. All right, I'm going to draw a line across to show kind of that we're starting our examples. That's kind of the overall big ideas of today. All right, we actually have 6 examples, which I know feels like a lot. It's okay. We'll be okay. It's going to be fine. All right, in our first example, we have k parenthesis x. Now let's talk about that real quick. When I see k parenthesis x, k is that name, and we read this as k of x. Nowhere would that be written down, k of x, unless they were trying to do like a transcript saying exactly what Miss Morel said today. She said k of x. But even then, they might even write k parentheses x, because we know in math that's how we say that. So k of x equals 6x plus 7. And we have m of x equals 2x squared minus 4. So again, to say that, we say m of x. If we put a number in there, like we put a 2, it'd be m of 2, k of 5. We use that word of to show that we're doing an input. All right, this is the point where you're going to color code if you'd like to with your colors. I'm going to do k in blue, and I'm going to do m in red. So if you'd like to use colors, you can. Pick 2 colors, doesn't have to match mine. You could use highlighters today, could be good use. Do them. They've just been sitting there. All right, our directions are to evaluate today. So evaluate, which means to find the answer. So for number 1, we're going to have k of 6. So first thing I need to do is decide which rule am I going to use. So in this case, which rule should we use? Are we going to use function k or function m? K. Yeah, how do you know? Good, it starts with k. So we're going to take that k, and instead of using x, what are we going to put in for the x? 6. So it says k of 6. So it says 6x plus 7. So 6. Instead of x, we're going to do parenthesis 6, because that's our x, and then plus 7.
A lot of 6.
So many 6s. All right, and then we can simplify this, so we use our order of operations. When we use our order of operations, do we multiply or add first? I'm going to multiply first, so it's 6 times 6. Good, 36. 36 plus 7, 43. And to write it nicely, we're going to say k of 6 equals 43, and that tells our reader a lot of information. It tells us which rule we used, what we put into the rule, and what we got out of the rule. So which function did we use? What was the name of that function? K. Sorry, I didn't hear you. K. And what did we put into K? 6. And what did we get out? 43. So it tells us all that information. All right, number 2. K of negative 32. So again, we're using our functions. We're deciding which function to use. Are we going to use K or M? K. And our first step is going to be to substitute or to replace our X with that input. So whatever color you've colored K, you could color that in to show that matches. So we have 6X, so we'll do 6, and then instead of X, what are we going to use? Negative 32 plus 7. Come here. You are so distracted today. It's the 5th time you took out your phone.
It's the second.
It's not. I counted.
The 5th time I took out my phone.
So 6, parentheses, negative 32, plus 7. We could do it in our heads or use our minds to figure that out. But we can also use Desmos at this point, because the goal of this lesson is to really figure out what do we get out when we put in negative 32. So what do we get out when we put in negative 32? Good. Good, negative 185. So k of negative 32 equals negative 185. All right, we have 4 more examples. I know it feels like a lot, but this is good practice as well as pretty straightforward for the most part. All right, number 3. We have m of negative 3. M of negative 3. So how is this one going to be different?
It's M.
Good, it's m. So how am I going to write out that function? Good, we're starting with that m, so 2.
2x squared.
Good, but what instead of x?
Parentheses.
Yeah, we're going to use those parentheses. Those parentheses are going to be really important because that's going to help our calculator do that work for us if we're using our calculator. And then minus 4. So the only thing we replace is that x. All right, we could do this in our heads. Which part do we do first according to order of operations? Good, exponents. So what's negative 3 squared? Negative 3 times negative 3? 9. 2 times 9? 18. And 18 minus 4? 14. Double check. 14. So m of negative 3 equals 14. Okay, as long as we use parentheses, we should be good. If I didn't use parentheses, let's just take a look at that. If I did 2 times negative 3 squared minus 4, do I get the same answer? No. So it's really important that that negative gets put in parentheses because for some reason our calculator looks at that negative 3 and doesn't know the negative goes with the 3. They think that negative and 3 are separate. It gets confused. I don't know why. Don't ask me. If I made a calculator, I'd be like, do it the other way. All right, number 4. Again, we have 3 more examples. You guys are crushing this. All right, this one, try and work ahead on m of 6. So write out what we're going to be putting in our calculator. You can throw it in your calculator already. I'm only going to give you about 45 seconds to a minute. All right, so first step is to go back to our functions. Which function are we going to use?
The red one.
Good, the red one, m. So how am I going to write that out?
2 parentheses 6 squared.
Good, nice job, Zach. Nice job, Camille. You both had that. Okay, and then if you wanted to work through it in your head, you could. What would you do first? Good, 6 times 6, which is 36. What's 2 times 36? 72 minus 4? 68. Holy moly. Ephra is a human calculator. Oh, you used a calculator? Oh. You just knew all the answers. That was impressive. So m of 6 is 68. All right, those are kind of the basic ones. We're going to take out the training wheels because we can't always ride a tricycle for the rest of our lives, right? All right, ready for 2? These next 2 are our last 2. They're going to be a little bit more advanced. Here we go with number 5. Number 5, we have k of x plus 3. K of x plus 3. So first off, which function are we using?
K.
K, good. So what's different about this one? What makes this one a little more advanced than the others?
It doesn't have one. It doesn't have one number. It has multiple.
Good. There's multiple things in it, and what else is in the input there? X. So that means our answer is going to have an X in it. We're not going to get to one final answer, but we're going to simplify our answer as we work. So I'm going to go back to K, way up here at the top. I have 6x plus 7. So I'm going to write 6. And then instead of x, we're going to put in the parentheses our input, which is x plus 3. And then we still have a plus 7. Because that's at the end. So all we did is instead of x this time, we have x plus 3. And we need to simplify this as much as possible. According to our order of operations, we would do this adding first, x plus 3. Can I actually combine x and 3? No. So how am I going to simplify this? How would I get rid of those parentheses? Distribute. Pew! Pew!
But doesn't x equal 1?
No, we don't know that x equals 1. It would be 1 times x, 1x, but x doesn't equal 1. X could equal anything at this point.
Okay.
The coefficient would be 1, yes. All right, so we can show that out if you forgot about distributing and you need to write yourself a reminder. That's 6 times x. And then we also do 6 times 3. If you need to write that step in there, you can. If you feel like you got that and you remember it, it's in your memory, you don't need to write it, that's fine. So what is 6 times x? 6x. And 6 times 3? 18. But then I still have this plus 7 hanging out at the end. So what's my last step going to be simplifying this? Adding what? Good. 18 plus 7 are constants. So 6x plus, what's 18 plus 7? 25. And then I'm going to rewrite that out as k of x plus 3 equals. Now, this is a pretty simple example. The reason why we would do this is if for some reason we had data and then we wanted to add 3 to all of our data points. So let's say we're taking data of something right now and we want to know 3 years in the future of all of that data. Rather than finding all the answers and then trying to find the final answer, we can just, let me say that again. Instead of adding 3 to all of our, instead of adding 3 to all of our data points and then plugging it in, we can just take that new number and put it into 6x plus 25, and it changes it considerably. When we look at something in the future, 3 years in the future, it doesn't just mean we're adding 3 to our answer, it changes kind of everything with that adding 3. All right, last one, number 6. Again, this one's a little different, a little advanced. Number 6, we have m of negative 3 plus k of 6 plus 2. All right, so what would we need to do to solve this, evaluate this expression? What would be our first step? Yeah, we have to plug in each part. So I'm going to kind of just do this little dash down the middle here. So we need to know this m of negative 3. So I'm going to go back to my function m, which is 2. And then it's x squared, so negative 3 squared minus 4. So I put that into my function m. Which we already did this one. It was one of our examples already. Which example? Number 3? We already found our answer in number 3 for this. What was our answer to number 3? 14. So we get 14 plus, and now we need to do the same thing with k of 6. So k of 6, we're plugging into that function k, which was 6x, so 6 times 6, plus 7. And we actually already did that one as well. What example did we do that one for? Yeah, that was number 1. What was our answer?
30.
We had 36, but then we added 7. So our final answer was 43. And then we also have to add...
7?
Nope, we already did that with that 43. Then we have to take this 2 on the end and add 2. And then we're just adding those together. Anyone got that in their head? 14 plus 43 plus 2?
58.
59. Close. 14 and 43 is 57, and then plus 2 would be 59. So again, we'd write that out really nice and professionally. M of negative 3 plus K of 6 plus 2 equals 59. How come, one last question before we finish off real quick. How come in example 5, when we saw that plus 3, we put that into the function, but this one when we saw plus 2, we just put it at the end? Good, it's not inside the parentheses. This plus 3 was inside the parentheses, meaning we had to do it in the function. This plus 2 was just added on at the end. Crushed it. All right, so I know a couple of you are missing some